And then let's go ahead and take a look at the content for today. So most of the days that we are here in class, it is going to be hands-on, kind of doing great things, interesting things with VBA. We're gonna touch VBA just a little bit today, but today's more of a theory. It's more of a background lecture. Anyway, little review from last time. We got introduced to kind of three specific terms. There's one, I gave you a word that we're going to be working with quite a bit during this semester, and I told you it means thing. And what was that word? Object. Yeah, so objects are just things. There's a particular kind of thing. We can say it's a thing. It's a thing that we can manipulate through code in VBA. There are two characteristics of objects that we're going to need to get really comfortable with. And you remember what one of those characteristics is called? Go ahead. So methods, yeah. So a method is something that an object knows how to do. So objects have a little bit of code built into them that they can do specific things. And so one of the things that we saw was like selecting a range. A range, when you tell a range to select itself, it says, oh yeah, I know how to make myself the active cell or the active range or the selected range. And so you can say, identify some range, the object, dot, call the method, select, and it does that functionality that's built into it. So that's right. Properties are one of the really important characteristics of objects. And what's the other important characteristic of objects that we got introduced to last time we were together? Properties, yeah. So a method is something the object can do. A property is just some value that says something about the way the object is. In fact, really what that property is, it's just a variable. We're talking about variables today. It's just a variable that's built into the object. It's a place where we can store a little bit of data. And it's a part of the object. Okay, so let's talk about variables and constants today for VBA. There is, in the physical hardware of the computer, there is one place where I could store a value and kind of have ready access to it from whatever processing I'm doing. And I could kind of let it sit around for a few minutes, and I could call it back and say, hey, what was the value that I put in there? And then I could change it, I could update it, and then later on ask again, what was it? And what is the name of that place in the hardware of the computer that we can do that? There's a name for that little piece of hardware that allows us to store value and then call it back later. So you don't have to raise your hand, just call it out. RAM, yeah, random access memory. This is what it looks like. It's a little chip of memory. And you've got, how much memory do you have, by the way, on your computers? Like how much memory do you know is on this? Terabyte. Okay, now that's terabyte. That's going to be like a terabyte of storage. So that's going to be stable storage. And the whole point for stable storage is that when you turn the power off to your computer, that storage doesn't go away. But random access memory is volatile. Stable storage takes a little bit longer to access it. RAM is really, really quick. And gosh, is it even possible? I've never heard of a machine with a terabyte of RAM. It's possible. In fact, like the operating system, like Mac OS or Windows 10, could access that much memory if we could invent a computer that had that much memory. So someone who knows how much memory they have, go ahead in the back. 16 gigabytes. That's a pretty common amount of memory on a decent computer. So 16 megabytes, and we're going to give you a feeling for just about how much data that is today. So that's good. So that's where you can. The idea is it takes power to be able to keep the values there. You plug a value in there, and you can read the value back later. In memory, everything we're dealing with has to be ultimately reduced down to ones and zeros. And so it might be a magnetic charge. Actually, a magnetic charge is positive or minus, plus or minus. If it's some kind of optical media like a DVD, it's just like a burned pit, or it's either burned a little divot there or not a divot. But ultimately, everything gets down to being a set of ones and zeros. And so the question is, how are we humans, we mere mortals, going to be able to deal with all these ones and zeros in a way that they make sense to us? And that's where variables are going to come in handy. So here's a definition of a variable. A variable is a location in memory that has a name. So it's a named location in memory where a value of a particular data type, we'll talk about data types in just a minute, can be stored and then later retrieved. So variable is kind of a complex idea. It's a location in RAM. that we give a name to, because the truth is we don't care where it is. We just want to say, hey, let's just name some location in memory, and then we'll refer to that location by its name. In fact, it's like, how comfortable are you with the difference between operating system software and application software? If I say those two terms, how many of you are saying, 5 is like, I could explain that to my mother, the difference between application software and operating system software? And if you're saying, you know what, I don't even know what those two things are, that's like a 1 or a 0. So just show me on a scale of 0 to 5 how comfortable you are with that. I'm seeing 2s, 3s, 5s, 2s, 1, 2, 3. Okay, so maybe just a little background here. So the operating system software is the software that works with the hardware. So you got the actual parts of the computer that you can touch, the physical hardware there. The operating system's job is to interact with that hardware and kind of be the go-between between application software. Application software is like Word, Excel, a browser like Chrome or Edge. What's the graphics kinds of software? Photoshop, Adobe Illustrator. So the kind of programs that you actually use to get stuff done, that's called application software. And way back in the early days, well, we don't have to go that far back. Anyway, the whole idea here is, if you're writing an application, instead of you being able to say, listen, I got to be able to figure out how to work with all the different kinds of hardware that this might want to be able to run on, we have application where we have an operating system hardware, we have operating system software that says, I'll deal with the hardware, and then application developers just have to deal with that operating system. Like follow the rules that operating system uses, and then we can kind of work across hardware. It's a really nice thing. And so what happens is, when we need to create a variable, our application software, in this case Excel, is going to say to the operating system, in this case up here, Windows 10, I think, going to say, hey, I need some memory. And the operating system is going to allocate that to the application software, and that's when we're going to be able to use it in VBA. But let's kind of think about this kind of at a low level for just a little bit. And folks, most of the stuff that we're going over today, if you're thinking, oh boy, this is a lot to remember for the midterm, most of this stuff is just like background that I'm giving you to help you kind of have a general feeling for what we're dealing with. Midterm examination, there's going to be some stuff on this about the midterm examination, but I'll point that out. Like the things that are like important for you to think about for midterm, I'll point that out. So even though the very lowest level of information that we deal with in memory is a bit, it's short for binary digit, it's just on or off, 0, we think of it as 0 or 1. The smallest amount of memory that we will ever address from VBA is going to be 8 bits at a time. And we refer to 8 bits as a byte. Why is it called a byte? I don't know. There's probably a good reason for that. I could have looked that up and figured that out before class today, but I've never thought about that question before. So we work with 8 of those at a time. And so if we think about what we might be able to do with those 1s and 0s, this is kind of how we represent a number. So what we're saying is, listen, we've got 1 bit here, and that's either on or off. That's the units column. And it's, if I have a 1 there, it really means the number 1. What else? What symbols can I put in that first place? Yeah, 0 and 1. There's only 2 symbols that we can work with. So our next column here then is the 2s column. If I have a 1 here, what does it mean? Like the whole number that I'm representing here, if I've got a 1 in the 2s column, what's the total number that I'm representing? Well, it's 3 if it's a, well, let's take a look. I'll probably have those things right here. There's a 1. There is a 2, right? It's 1 in the 2s column. Oh, I was going to go to the next one. There's a t-shirt in the way. So yeah, so 1, 0 in binary is the number 2, right? Have you seen this? There are that many types of people in the world, those who understand binary and those who don't. Yeah, how do you actually read? How do you read that? There are 2 types of people in the world, those who understand binary and those who don't. There was another joke here. Those who understand binary and those who have friends. I don't know. Anyway, so now what we're saying here is that if I'm filling this in, I've got 1, 2, and I've got 1, 1. And so that's, you know, a total of 3. 4. Right, so that's 1 in the 4's place. So I've got 1, 4. I've got 0, 2s. I've got 0, I've got 0, 8s, 0, 16s, 0, 32s. What is this number right here? That's 65. Oh, what is this number? I think I heard someone say it. Say it a little bit louder. 255. How did you do that so fast? You must be a math genius, because you did 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128, and you came up with 255. How did you do that so fast? Ah. Okay, so interesting. So let's go back just a bit. Okay. When I want to add one more onto this, I've got 3 here, and I want to add 1 more, right? I can't fit any more here, so that means I've got to get one of the next column, and then zero out all of these. And that happens, right? When this one gets all full, and I try to add 1 more, I'm going to get 1, 8. That would be 7. It would be 4 plus 2 plus 1, 7. I want to add 1 more. Well, that's 1, 8, and 0, 4, 0, 2, 0, 1s. So if I was here at 256, so this is, right, so this is 128, 64. If I add all those up here, it's 255. What's the next number in this sequence? If there was another number here, what would it be? It would be 256. So when this is all full up here, it is 1 less than when I have just 1 in the next place with 0 more going over. So this is 255. The next one would be 256, but this one's just 1 shy of that, and so it's 255. Are you going to have to know how to manipulate like binary numbers for the midterm exam? No, not at all. So this is like background to kind of understand how, get some sense about how this actually gets implemented. So what's the range? What's the possible range that I could represent if I've got 8 bits of information? If I've got 8 bits to work with, what's my possible range that I could use to represent a number? I've got 256 different values, and those would be from 0 to 255. And so if I have twice as much memory, instead of 8 bits, I've got 16 bits or 2 bytes. I can probably do twice the range, right? No, like dramatically more, because each bit I add doubles my capacity. And so if we look here, here's now 256. It's not quite wide enough to line them all up, so you kind of just pretend that these are lined up next to these over here. And so there's 256. I add 1 to the next column and 0 everything else out before it. Oh boy, what is that? I guess that's 1,000. I'm sure we could do the math, and that's probably still right from the time I made these slides. And so, okay, so that then actually gets us into something we could actually do in Visual Basic. So let's go ahead and open up Excel, and let's take a look at now this first data type. And this is something that I want you to know for the midterm, what the data type byte is. So I'm going to open up Excel. I'm going to come to my Visual Basic editor. Used to be a tall chair in here. Now it's disappeared. I'm going to have to stand. I got to stand. Whew. Now, last time we recorded ourselves making a macro, and that the macro recorder said you're going to need some place to put this VBA code. Because we're not recording a macro, we're starting with a brand new workbook. We're going to have to make that place ourselves. Now, listen, there is only one place in all of VBA that we can store code that will like get saved with the workbook. And that's a thing called a module. There are a few different kinds of modules, but we got to have a module for that. And when I start recording a macro, it makes a module for me. But we're just going to insert a new one. So we'll come to the Insert tab right up here, with the Insert menu, and then we will choose Module. And that's given us a module here with a great name, Module 1. And here it is, just a completely blank module. And I'm realizing something here is kind of interesting. How many of you, when you opened up that module, it said option explicit here at the top? Just raise your hands high if you say just one. Let's go ahead and change that. A couple of you have that. We're going to make a change here that will make your lives better in this class and for the rest of your life programming in VBA. We're going to tell it to, we're going to change a setting. We'll change a couple of settings here in the editor. So let's come to tools and then options. And we're going to make two changes in the way that your VBA is configured. The first one right here is auto syntax check. I'm going to uncheck that. Now, the truth is, it's still going to check your syntax for you. But if you have the auto syntax check checkbox checked, then when you have a syntax error, you've done something that's not quite perfect on a line, it will put up a dialog box. And folks, we're going to write a lot of lines that aren't quite right in this class. And if it puts up a dialog box and nags us every time, it gets to be quite annoying. So we're going to turn that off. And then we're going to check the next one where it says require variable declaration. Let's go ahead and turn that on. Now, for what we're doing today, it won't really matter, but let me go ahead. I'm going to get rid of this and just show you the difference now that we've got that require variable declaration on. I'm just going to remove module 1. And again, I encourage you not to do this, just to watch this part. I'm removing module 1. This is terrible because it asks you, do you want to, it's like you think this is saying, are you sure? That's not what it's saying at all. Do you want to export that blank module before you close it? No, I don't. Okay, so it got rid of that module. And I'm going to insert a module again. And now that I have require variable declaration, is that what it was called? Then it's going to come up here and put an option. Folks, you could just type that in at the top and it would do just exactly the same thing as creating. What that says is, and we have to kind of understand something about the philosophy of VBA, like in the early 1990s, when they're thinking about VBA, when they're thinking about the language, its predecessor, just Visual Basic, they said, listen, we want to create a language that is really user-friendly. A language that's not so picky that you get everything exactly right. In fact, in every other language that I know, if you want to use a variable, you have to declare the variable. You have to say, this is how I want to set up a variable to be able to access the memory. In Visual Basic, for applications, let's say, listen, if you just use a variable without declaring it, the interpreter will say, oh, my poor, sorry programmer, he's trying to use a variable without declaring it. I've got his or her back. And it will just declare a variable for you to use it, even though you just have to start using it and it will declare it for you. There's a couple of problems with that. And I'll talk about them in a little more detail here, but the big problem is that one of the hardest errors in your code to track down and fix is a misspelled variable name. Because if you just transpose a couple letters into variable name, in this environment, they'll go, oh, new variable you haven't used before. I'll allocate memory and you'll have a new variable. You'll have two variables, two different places that you're writing data in memory, thinking it's the same one. And that is really tough to track down. And so you're going to think about this as a spelling checker for your variable names. Because it's going to say if you're going to use a variable, you've got to first declare it. And that's what we're talking about today. So that's just what that option is. And it's a good idea to have it on there. Now, when we recorded that macro last time we were together, it made a block of code. This started with the keyword sub. It's short for sub procedure. And it ended with the keyword end sub. I'm just going to write this one from scratch. Sub, and we're going to call it variable demo. I'll hit enter, and it automatically puts the end sub in here for me. That's nice. And it put these opening and closing parentheses. Those are syntactically required to be there. It lets us do some kind of fancy things on the inside of those parentheses, but that's not for today. So for today, it's just opening and closing parentheses, and then we'll deal with it. Okay, so now our data type that we're looking at here is, this one is called byte. That's actually the name of the data type. So remember, a variable is a location in memory with a name, and it has a type also associated with it. So let's just go ahead and declare a variable right here. I'm just going to declare a variable called x as byte. In the very early days of BASIC, not only did you not have to declare your variables, but you couldn't declare your variables. There was no mechanism to declare your variables. Now, later in the class, we're going to learn how you could declare thousands and thousands of variables all at the same time with a construct called an array. And from the very beginning days of BASIC, the way that you made array was you used this dim statement. You were setting the dimensions of the array. It could be two-dimensional, it could be a one-dimensional array, a two-dimensional array. And the dimensions, like how many variables you kind of want in each one of those. If you think of it as a grid, you're setting up how big that array of variables is. We'll talk about arrays later. That's the origin of this term. So it's short for dimension, and it comes from this kind of more complex idea of making an array, but we're just allocating now some memory. And how much memory gets allocated depends on the data type that we use. And so here I've said dim, which says, hey, we're making a variable. X is the name of the variable. And then I say as some data type. So can you guess how much memory we are allocating with this command? 1 byte. Yeah, and this is what it looks like. So it's just 1 byte. And so the range for the byte data type is 0 to 255. Is there any way for me to record 1.5 in this structure? No, it isn't. It's integers only. And that's how we do it. So we've declared that variable now. I'm going to go ahead and put a value into that. And here's how we put a value into it. X equals 5. So this is referred to as the assignment statement. We are taking what is on the right-hand side of this equal sign, and we are putting it into what's on the left-hand side. Here's the next one that we'll do that if you didn't have me to help you understand it, could be really confusing to look at. I'm going to say this. X now equals X plus 1. Now, if I was looking at this as a mathematical equation, that would be really, really confusing. In what situation does X equal X plus 1? There's only one value for X where that statement is true. And what is that value? We got someone who's got some math behind him here, don't we? There's a single value for which that equation could be true. X is equal to infinity. That's the only time it would work. And it's a really, really weird thing to say, but it's not an assertion of equality. It's not an equation. It's an assignment. What we're saying is we want to put a new value into my variable. I made a variable called X. It's a location in memory that has a name. I think of it as X. I want to put a new value into this. What is it? What is that value? Well, here's where I put the initial value of 5 in. So now, as I'm trying to figure out what value goes into here, I'm saying it's going to be what the current value of X is, which at this point would be 5. I'm going to add 1 onto it. And so this whole thing is going to evaluate to 6. And I'm going to put the value 6 into X. And so now if I say debug.print X, and by the way, debug.print just allows you, we've got a thing called the immediate window in our Visual Basic environment that just allows us to see output. And debug.print is the way that we get output there. Mine's not showing here, by the way. And the way you get the immediate window, if you're not showing it, choose View, Immediate Window. And I'm going to bring it to the top because it's a little bit more visible here in the room to be at the top. Okay, so now, if I come here and run this sub-procedure, and I can run it just by clicking on the little green play button right up here, it will allocate the memory. It'll put a value of 5 into it. It'll change that to a value of 6, and then it'll print whatever value is in that location in memory. And so it prints 6. Show me how comfortable you are with what we've done so far in class today on a scale of 0 to 5. 5, 2, 5, 5, a lot of 5s. Okay. So now let's do something. What's the largest value I can put in here? 255. In fact, what would happen? I mean, you look at that. Let's see, where's my ones? I look at that, all full of 1s. What would happen? It's completely full of 1s. What would happen if I tried to cram another 1 in there? What would it do? If you had a cup and it was completely full and you tried to put more in it, what would it do? It would overflow. Now watch what happens here. And it seems like a really weird word that we're going to see here, but let me put in x equals 255. It should take that just fine. And then when I get to here, that should have an error. Let's see what the error is. I'm going to run that. And it tells me I have an error, and it's error number 6, overflow. And I'm going to hit debug, which will show me where the error happened. See, it took this line just fine. This is where it failed because I tried to cram too much into it. And if it let that happen, what would it do? It would overflow. There'd be like a little bit rolling around inside my computer. You'd shake your computer, it would rattle a little bit, you know, with that up. And so that's what that means. So when you get an error, overflow, it means you tried to put something into a variable that it just couldn't take. You tried to put something that wouldn't fit. What if we do this? X is 0, and then x equals x minus 1. I'm going to stop this code and run it again so it runs from the beginning. Same thing, it's an overflow. Somehow in my mind, I think it should be an underflow, but it's an overflow. Overflow means you tried to put something in the variable that couldn't fit. Questions here? Yeah. Oh, yeah. So if you think about what would normally happen here. So if I was to add one more into here, it would like tip this one up to 1, and it would put all of these to 0. In some programming environments, like if you only have 1 byte allocated and you added 1 into it, it would do exactly that. It would pop this one over here to 1, even though it's not part of your variable, and it would set all of these back to 0. And in VBA will not let you do that. Like if you try to put a value that won't fit, it says no, and it will give you an error and say you cannot do that. That's good. Another thing it does, by the way, when you declare the variable, and if you're in an environment where that little case that we just described would happen, when you make variables in those environments, like there's always, like every bit is always some value, 1 or 0. And in some environments, like when you declare a variable, like what's in the variable, whatever happened to be there left over from the last time that memory was used. But in VBA, it will always reset your variable. When you declare it, it resets it to a default value. All numeric variables are reset to 0 automatically when you declare it. So even if we didn't set this to 0, it would start at 0. And if we ran this, we would get exactly the same problem, because it's trying to go negative. In fact, if we just skipped that line and ran it like I just dragged the yellow point past that line. Just going to print the value of x. We've never set it, and it's going to give me 0 here, because that's where all numeric variables start. Okay, other questions? Let's see, where was I? 2 bytes, 2 bytes, there's the byte. Okay, so next data type that we have is called integer, and its range is what? This one's a little bit interesting, because this one doesn't actually start at 0. So let's look at a couple other things before we talk about the range as integer. But we'll know it's bigger. So let me just kind of back up here. And instead of declaring this as byte, let me declare it as integer. I'm going to leave that in there as a comment. The way we put a comment, single quote, that will disable that line of code. And instead of declaring this as a byte, I'll declare it as an integer. And so now integer is integers only, but it uses twice as much memory, so it has much more range, including negative numbers. So whether I'm starting at 0 and going down, or starting at 255, what have I done? Or starting at 255 and adding 1, then we don't have the same problems we had with byte, because it's got just a little more memory, and it can handle those values. Okay. So when we declare variables, the thing we have to realize is that every single one of these 1s and 0s in memory has its own address. So that one right there is at that address. And I think I'm giving you the address in two different ways, either a decimal way to refer to the address, that's a numeric value, or this one is hexadecimal. So this is base 16, this is base 10. It turns out base 16 is a lot easier to work with in computing stuff because the base is a power of 2. And since we're working up from binary, base 16 ends up being much more convenient than base 10, even though you and I are used to thinking about things in base 10. Like the very next one over has like the very next number. That's the next location in memory. Every single one of your bits in memory has its own unique address. That's for what's stored at that location. In fact, when you talk about your operating system being a 32-bit operating system or being a 64-bit operating system, what it means is how many bits does it take for you to address memory? So if you're a 32-bit operating system, it means your address space is 32 bits long, which means you can only reference 4 gigabytes of RAM. Like if you have a 32-bit operating system and 16 gigabytes of RAM, you're only using 4 gigabytes of them because your operating itself, the memory address space, can only deal with 4 gigabytes. So 16 gigabytes, so if you've got a 64-bit operating system, it can do like dramatically more memory, like way more than we can build yet. Okay, so we dimmed x as integer, and you'll see now that I have some of these bits are shown in a gray background. What I'm trying to express here is that if it's in a gray background, what we're saying is the operating system has allocated that memory to some application software. And so when I say dim x as integer, the operating system says, great, you want 8 bits. I'm sorry, it says integer, so it's 16 bits. You want 16 bits of memory? It goes, great. Here's 16 bits of memory. I'm going to make sure that no other program can access that besides you. And it will hand back the address of where those 16 bits start. It just says they're going to be contiguous bits, and it's going to start at some address. The operating system says this memory now belongs to you, Excel. If someone else tries if some other program tries to access that memory, the operating system will terminate that program. Like it's the job of that operating system to say, like to halt the program, like midstream. It tried to access something it wasn't allowed to access. That's against the rules. So it allocates that just for Excel to be able to use and gives us back the address. Now, as a VBA programmer, I don't want to deal with the address. In fact, I don't even care where it is. What's the likelihood that the next time I run my program, it's going to get that variable will be located in exactly the same location in memory? It's like crazy small likelihood that it would end up in the same place. And so we say, listen, I don't care where the memory is. I don't care what the address is. Operating system, give me some memory. It says, great. And it hands it back to VBA. Now, as a programmer, I'm telling VBA, I want to call that location in memory. I want to call that X. And VBA then connects that variable name X up to whatever address the operating system gave back to it. And I think about it in terms of its variable name. VBA handles mapping it into a memory address that it can use to actually put values in and pull values out. Questions? I wonder what we have stored in here. It's a 1, no 2s, no 4s, 1, 8. I don't know. We could find that out. That's some number that's stored there. So that's the location where that one is, and that's the value that gets sent back then to the operating system. Start to that location, and is 2 bytes long. So now the question is, how could we represent a negative value? We talked about the byte data type. The range is from 0 to 255. So how do we do negative? So here's what we do. We take the stored value. We're storing some value, thinking of it as just counting it from 0. But instead of taking that value and counting it from 0, we count it from some negative number to start with. So in this case, we are storing the value 1,000. If I was just to look in the bits that this variable is stored, it would just add up to 1,000. That's probably what was there. An 8, a 32, a 64, a 128. Anyway, that comes to 1,000. But instead of counting at 0, it starts counting at negative 32,768. And so what number is this actually representing? If this is an integer data type, like that's negative 31,768, because to be able to get some negative numbers, we start counting, like we have a quantity stored in memory, but to actually get that to its value, it starts counting from a negative number. So if the bottom of this range is 32,768, if I just put that number in here, 32,768, and try to subtract 1 off of it, let's subtract 0 off of it, which will not change its value. That should run just fine. Integer 67, 3,767. I might be off by 1 number here on the slide. Let me try to subtract 1 from it. Oops. Well, that should be negative. That was the problem. Let's start off at negative. I think 8 is correct. I'll comment that line out. That should be okay. Yeah, so it prints negative 3,768. But if I try to subtract 1 more off of that, it should fail because it's going to overflow. It's going beyond what the range can handle. So in this case, we've got everything filled up, up to here. So instead of 32,768, I don't have this one. So we've got everything filled out before it. So that's 32,767. So if I start from the base number and count up, that's how -1 is represented. Here's 32,768. That is how 0 is represented. That's how 1,000 is represented. Because if I was to look at this bit, like this bit by itself turns to 1 when the number is no longer negative. So whether it's either 0 or a positive number, this will be a 1. This is sometimes referred to as the sign bit. Like one of these bits, if I could look at it at that bit, it would tell me is the number positive or negative. So is it non-negative, or is it negative or non-negative? And if we fill it all the way up, 65,535, but we start counting from negative 32,000. And so what I expect you to understand for the midterm for the integer data type is it's roughly plus or minus 32,000. So you don't have to get down to the specifics, like all the way down to the digit, but about 32,000 plus or minus, that's what you can store. Now, you might say, what do I care if I use integer or byte, or in this case, the next one that we're going to talk about, which is long. I've got like 16 gigabytes of data storage. What do I care between saving 1 or 2 bytes? Generally speaking, you don't care. We're going to see later in class how we can declare, literally, we can declare tens of thousands of variables all at the same time. And there are reasons why you might want to do that. So I do want you to have a little bit of background in these data types. So basically plus or minus 32,000. The next data type is a long integer, and it's just called long. It's a 4-byte number. And so it's basically plus or minus 2 billion is the range. How do you actually declare this? Just instead of saying integer, you say long. And so now I'm able to go outside the range of integer, and it's short for long integer. There's one more data type. It's not on the slides, and I'm not going to expect you to know it for the midterm. And it's only available in 64-bit versions of Excel, but it's called long. It's like twice as long. Long. Like up to the 32-bit versions of Excel, long was the biggest integer you could have. And that was enough. That was enough to be able to like map to, like have a different value for every memory address. But with 64-bit operating systems, you couldn't do that anymore. So they made this new type called long. Its range is absurd. I'm not sure what it is. Okay, so the 3 data types I want you to be familiar with that deal with integers are byte, integer, and long. Now, how do we do a decimal point? There's a couple of ways that we can do it. There's a thing called this is called a fixed point number. I'm going to show you the data type that VBA uses a fixed point number for. The idea is you want to store a decimal value. Say, listen, there's a data type that has 4 digits of precision. We'll see it here in just a second. But what we'll do is we'll just say, listen, just store the integer portion. Forget about where the decimal is, and just store the integer for all of your digits. And then Visual Basic just knows every time I read that, I just have to move the decimal place over 4 places to actually get to the number that you're actually storing. So there is no fixed point that's 2 bytes, but this will help you understand the idea. Is that if I have this all the way filled up with ones, that value is, the raw value stored is 65,535. Move the decimal point 4 over, and that's what number is being stored there. So we don't have to think about where the decimal point is. The decimal point is always 4. It's like over 4 from the left, from the right. If we had different values stored, you're doing that. So the data type that is that way is called currency. And so it's roughly 922 billion, plus or minus 922 billion is your range. But it takes 8 bytes for every currency variable. Big enough to store our national debt? Not even close. Like, not even the right order of magnitude. Okay, there's a second way that we can store a decimal point. So the currency is what we refer to as a fixed point number, which means whatever I've stored, the decimal place is always, I've always got 4 digits of precision, 4 digits past the decimal point. The other kind is called a floating point number. And the idea is I'm going to use a portion of the memory not to represent the digits that I'm trying to store, but a portion of that memory is going to be reserved to tell me where the decimal point goes. And so imagine this, there is no floating point number in VBA that's only 2 bytes, but this is just to kind of understand the idea. Is we say, listen, I'm going to use these 4 bits to indicate where the decimal place goes. So with these 4 bits, where could the decimal point go? I mean, I'm saying I've got to move the decimal point over some number from the right to be able to figure out what this number actually is. Like the rest of this is going to show me the digits I'm working with, and this will show me where the decimal point goes. So how many decimal points could I possibly have? Like how many digits past the decimal point could I possibly have if I'm using 4 bits to keep track of where the decimal is? Yeah, so I could store a number in here. If I put ones in all of this, the number is going to be 15. So that would say move the decimal, whatever this number is, move the decimal point 15 digits. In this case, it's no digits, and so the number that I have stored here is 3,574. It's just the raw value that these digits show up to. Here, if I say it's 1 decimal point, then it just, the same digits, I haven't changed. Like if we look between those 2 slides, all the rest of the numbers that show the digits I'm dealing with, those don't change. The only thing that's changing is the decimal point. And so, there's move it over 3 points, and there's move it over 15, right? So I could store 0.000000003574 just by changing where the decimal point goes. So this is what's referred to as a floating point number. You see why it's called a floating point number? We store the digits, and then another part tells us where does the decimal place go in those digits. So here's your 2 types, your 2 data types that are floating point numbers that I want you to be comfortable with. So one is called single, and that is short for single precision floating point number. By the way, watch what happens here. What do you think is going to happen if I say x is going to equal x minus 0.5? Now, this is long data type here. Go back to just long, since that's one we're working with. What's going to happen? What do you think? I'm trying to put it in 0.5. Can this data type take a 0.5? It's short. This means long integer. It can't. So what might you expect to happen here? If you're going to guess, just take a guess. You would just think, and in fact, a respectable programming language would give you an error. You tried to do something that just wouldn't fit. It should be an overflow. But VBAs, the whole philosophy is we're going to just try to figure out what you meant if you didn't quite do something right. And so let me clear these off. I'm starting it out. Let's do this positive instead of negative because it's a little easier for me to think in terms of adding than subtracting. So I'm going to run that. And it says, no problem. We're starting at this. We're trying to add 0.5. It doesn't do anything. What happens if I try to add 1.5? Then yeah, it takes it up in that case too. Really? 0.5, it doesn't add any to it. 1.5, it adds 2. I just got to check that because even I don't think it should be that. Let's go back to 0.5. 0. So yeah, okay, I'm sure even 5.1, it would go up to 2 in this case. Or it would go up to 1. Pulls it up to the next one. So yeah, it's like making its best guess. And its best guess is kind of weird here. Okay. So, but this one now, instead of long is single. Stands for single precision floating point number. Be glad you don't have to type that out every time you want to make a variable. Just single. And now it should take that just fine. It can handle the decimal point just fine. You get the 0.51. Single precision looks like it's accurate to how many decimal points? 1, 2, 3, 4, 5, 6, 7. So it's only accurate to 7 decimal points. So how many bits are being used on this data type to determine where the decimal place goes? Just 3 bits. You can get any number up to 7 you could use. All right, single precision floating point numbers take only 4 bytes, but these are precise only to 7 significant digits. So you can do really huge numbers, but you know what? You're only precise up to this little bit. Double precision floating point number, twice as much memory, crazy range, but now you've got 15 digits of precision. Questions? Little disclaimer here, the actual way that they implement this is a little bit more complex than what I just showed you. But that gets you to the idea of a floating point number. True or false? How does it store true or false? So in the world of VBA, 0 means false. And any other number means true. But if you ask VBA to convert false to a number, it will always convert it to -1. Why does it do -1 instead of +1? There's probably a good reason for that, but I don't know what it is. So in fact, let me just kind of here. Another thing you can do with the immediate window is you can just immediately execute a line. So you can write VBA code here that doesn't get stored with the workbook. You're just like testing something out. So if I was to say, there's several like functions in VBA that will convert from one value to another. So let me just do this. Let me print. I'll do the same thing, debug.print. Convert to integer, CINT. And I'll put in here 1.5. And so this then this function, cint, takes this argument and then converts it into an integer. Well, let me convert that to a true or false value. The bool. So anything that's not 0 should equate to true. 0 should be false. Anything else should be true. If I convert a Boolean value, false, that'll convert to 0. So I'm converting a logical value, a true or false, into a number. It converts it to 0. If it's false, true. will convert to -1. So that's kind of under the hood. That's how it actually does it. But we have the data type. Oh, and interestingly enough, the way this gets implemented in VBA is with 2 bytes. Like it could do it with a single byte, but it uses 2 bytes. I don't know why. So, and it's just the difference between 0 and -1. That's how it actually stores it. The data type is called Boolean, and it's a 2-byte number that returns just true or false. Questions here? How do we do dates? Dates are done similar to the way that Excel stores dates. Have you ever had a date in Excel that you changed the format and that date just turned to a number? Right? It's because the way that Excel is storing that date is it's saying, oh, we're storing a certain number of days plus or minus some beginning index date. It turns out that the same thing happens in VBA. So we're storing the number of days on or before the initial date, which is December 30th, 1899. Kind of a crazy place to start. That's where they start. So here we are storing the number 27,945. And so that's from that beginning day plus that number of days is going to give us July 4th, 1976. How do we do a date and a time? Kind of same thing. We just, instead of just storing an integer, we store like a fractional value. So that is 9 a.m. on that same date. So it's the same number of days away, and 0.375 days gets you to 9 a.m. So the way that the data type that we have for that, we already talked about it. Yeah, it's just called date. And you can use dates for both dates and times. Takes 8 bytes. Questions? Okay. So far, everything we've done has just been numbers. Date, maybe not just numbers, but you can see how we're getting there just with adding from a particular index. So how do we ever get to letters? How do we ever store someone's name in a variable? And the answer is we're going to map characters to a number between 0 and 255. So we're just going to say arbitrarily 65 is A. 66 is capital B. 67 is capital C. We just kind of turn this on its side, and the same representation, 1 down through 128. We're storing the value 65 here. So I could store Adams, comma, space, John by my first byte storing 65, my next byte storing 100. That's what lowercase d is. My next byte stores 97. Now I get to this comma, and this is like, whoa, that's like not even a letter. That's okay. It's just another character. Happens to be number 44. 32 happens to be the number that we use for space. And by the way, any number that's smaller than 32 is non-printable. So it's like a tab character, which is number 9, I think. Or it's, well, we'll talk about some of those other characters in just a second. So this is how I would store in ones and zeros that John Adams. Every byte then gets mapped to a particular character. And the map that we use is called the ASCII, which stands, it's the ASCII chart, American Standard Code for Information Interchange. So we can see here, let's see. Yeah, so there's capital A is number 65. Capital B is 66. And what do we say for lowercase d? Here it is, lowercase d is 100. Here's a space at 32, and 0 through 31, these are all characters that we use for controlling devices. So you imagine the very early days of like of a printer. You would send to that printer 65 and it would go, great, print a capital A. And depending on the mechanism it was using to print, if it was like had a rotating head, it would just, when you send a 65, that printer would be like, okay, rotate to capital A and then strike the paper with it. But there's all kinds of things we have to do to control a printer besides just sending the letter. For instance, one of the things we have to do is a line feed. So number 10 is a line feed, like advance the paper. One of the things we have to do is move the carriage back. Whether you're moving the paper or you're moving the print head, doesn't really matter, but you're saying, hey, we got to move the carriage back to start printing again. And so like in the olden days of working with printers, like you could type over the same line if you sent a carriage return without sending a line feed. Like you could like write across it. You want to like write some other letters right over the top of it. You could do that because all these first characters are non-printable. You can't see them because they're meant for controlling the device. Like ringing the bell. Remember like a typewriter? Any of you ever like work? Did anyone of you here ever type on a typewriter? Like even just to play. You type along and it moves along, and when you get to the end, what does it do? Yeah, it rings the bell to let you know, hey, you better move back. You're about to type off the edge of the page. I mean, this stuff goes back long enough that we still had bells that were used for that, right? And what's the bell? Which one is it? Number 7 is the bell. Okay. Now, here's the interesting thing. So far, the data types we talked about before this one, they're what we refer to as they're fixed memory data types. You allocate the variable. You say dim x as integer. 2 bytes get allocated. It does not matter what you put in, what number you put in there. It will always use 2 bytes of memory. Working with characters is different because you could have like a long number of characters, and we don't want to allocate as much memory as possible every time we need to use some characters because that would be really wasteful. The largest string of characters that we can make in VBA is 4 gigabytes. You can make one string variable that is 4 gigabytes of data. And so you don't want to be using the maximum all the time. And so what happens is when you allocate a string variable, it immediately allocates 4 bytes. There are 4 bytes of overhead. And these first 4 bytes say, how long is this string? So in this case, what do we have? 11 characters? 1, 2, 3, 4. Yeah, I wrote it down here, 11 characters. So this is an 8, a 2, and a 1. This first 4 bytes says this string is 11 characters long. And then from there, from these first 4 bytes, we'll read the next 11 characters. And that's how it reads the data. So when we declare strings of characters, then how much memory gets allocated immediately is just 4 bytes. And what is in those 4 bytes? 0. It says there are 0 characters in this string. It takes 4 bytes to be able to say there are no characters. And then, depending on how many other characters we put in, we adjust how many it says there are here. And so this is a variable length, a variable memory length variable. So how much it uses depends on what we put into it. And so in VBA, every time you write a new value to a string, it actually goes and finds a new place in memory to write that new value. So because it might be too long, and you can imagine you can't just extend it because it might bump into some other memory. And so that's the way it does it. The data type is called string, and it's 4 bytes plus 1 byte per character. So if I was to dim name as string, I could now say name equals Shane Reese, our new president. Now, you'll notice that what I'm doing here is I'm putting quotes around this. I don't have to put quotes when I'm dealing with numbers because we use numbers so much that VBA is like, great, you want to use a number in code? Just great, use a number. But because we have other symbols that we use characters to identify, in other words, we use these letters to identify the variable name, we have to do something to say, hey, this is not another variable name. It's not some reference to an object. It's just a collection of characters. That's what the quotes do. So the quotes let me just say, hey, VBA, don't try to understand what Shane Reese means. It's just a collection of characters for you to deal with. So now if I print X and also print name, that should print whatever that number ends up being and our university president's name. Because this now has allocated the memory, and when this starts off, 4 bytes are used, and then by the time we put this in it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 4, 15 bytes are used. Questions on string variables? Show me how comfortable you are with string variables in 0 to 5. 5, 5, 5, 5, 5, 4. Okay. So we're dimming it as a string, and I guess we just did this to show it. So in this case, we can see here's those 4 bytes here, all zeroed out. But when we go to put something into it, there's only room for 1 more byte here. And I'm trying to put in 11 bytes. And so it can't fit. Like if it tried to write over this data here that's allocated to another system, like the operating system would actually stop Excel. Like in the middle, boom, dead. You guys don't experience that. But like when Windows was pretty new, that was a regular occurrence. You're working along and all of a sudden your application would just stop because the operating system was like, yeah, you just tried to access memory, weren't allowed to access. The world has gotten much better since then. So it says, hey, operating system, we need to find some memory that where we have 15 bytes in a row, right? 11, yeah, 15 bytes in a row. And it says, great, here's where you can have it. And then it will write in John Adams. If you want, to see how much I care about you and making these slides accurate, go through and figure this out. Those first 4 bytes are going to say 11. And then there's capital A, 65. There's lowercase d, 100. It really is. I don't think anyone's ever actually checked me on that, but okay. We got just a few more minutes. Let me introduce you to now a more complex one. There's a thing called an object. Now, object variables are, they're a little bit different. Let's think about what an object is, a range object. The whole idea behind an object is that it's some location. I mean, an object has it has several properties. Each one of those properties really is a variable that's built into the object. It may also have some code that it knows how to do built in there. And so an object has multiple values. It's located somewhere in memory and then has multiple values for it. So what are some of the properties that a range has? A range has an address. It may have a formula. We'll have a value, a column, and a row. All these are properties of the range. So we can kind of think of this as being a complex object stored somewhere in memory. It starts someplace in memory, and it's got all these different properties. And the way that I might refer to this is like this. Let's just go ahead and do that. I'm just going to take this line right here. I'm going to declare a range as an object, and then I'm going to bind it onto a variable. So better start a new one on this one. Sub object. Dim RNG as an object. Set RNG equal to range A2. Now, this variable name becomes a nickname for that object. So if I was going to plug a value into my A2 variable, my A2 range, I can do that by referring to the value property of my object variable. So what has not happened is we have not copied the variable here. That's why we use the keyword set. We're not copying what's in the right side and putting it on the left. We are just connecting up this variable to that same object in memory. So now when I say the name of the variable dot range equals 55, sorry, name of the variable dot value equals 55, that will put 55 into range A2. So I'll run that and then go look at A2 and we'll see it's got the value 55 in it. So normally an assignment says to take whatever's on the right-hand side and put it on the left-hand side. But here we're saying, no. What we're actually trying to do is just connect up this variable to wherever that object is. And so what an object variable is, and I'm not expecting you to totally grasp this today because it's a little bit complex. What an object variable is, it is enough memory to hold the address to another location in memory. All an object variable is it's memory, it's a memory address. We are storing a memory address. And so when we refer to that variable, it's like, oh, this is just an address. Go find where that object is in memory and work with that location instead. And so it doesn't have to be value. I could put in here formula equals, I'll put in a formula here, equals 55 times 2. I'm putting a formula into that cell. Now it's 110, but you'll see that the formula itself that's in it is that. So object variables allow us to just have like a shortcut name to refer to some object that we're referring to. And there are several reasons that we want to do this. I'm including it here, even though it's a little bit mind melting for you here on the second day of class, just kind of for completeness here. We'll get comfortable with it as we work through it in this semester. Okay, last data type. And that is one called variant. Oh, and then the very last slide is here. So variant is, I almost want to say variant is evil. But variant is like, you know what? If you treat a variant like an integer, it will behave like an integer. If you declare a variable type variant and you treat it like an object, it will behave like an object. You treat it like a string, it will behave like a string. So it's really, really flexible. Here's the downside. There's 22 bytes of overhead every time you declare a variant variable. And there's a really complex set of rules that it uses to decide what to do with a value that you plug into it. Like what happens if you have a kind of like a string version of the number 2 and you add onto it another string version of the number 2. If these are variants, it'll end up with 22. You'll say 2 plus 2 is 22. And it will behave in ways that you're not expecting because you don't know the rules. I don't even know all the rules. And I've been working with this stuff for almost 30 years. So just be aware of variant. There's almost never a good reason to use it. And if you do decide to use it, it's going to get you in trouble because you're just not expecting the way that it's going to behave. Okay, and then the final slide here is what I'm going to expect you to know for the midterm exam. And as much as I am kind of fundamentally against memorization, this is something that to be good at programming in VBA, there's some stuff you have to know. And data types, kind of this range, when you should use one versus the other, is one of those things. So maybe we should have just given you this slide at the beginning and said go home, but there it is. Any questions on variables? Oh, the title of this slide was constants as well. Constants are just like variables, except they're exactly the same as variables, except once you give them their value, you can't change them. You give it its value once, and it's not allowed to change. All right, folks, thanks for coming. No class on Wednesday. I will see you next Monday. Class dismissed. Oh, thank you. You're a wonderful crowd.